Hello, class. Well, today we're going to be talking about a bunch of different tools you're going to need to be able to use to do geometric proofs. Okay, geometric proofs. So, there are a number of tools that you need to be familiar with before we start doing geometric proofs. Okay, now we've already looked at some of these. Okay, very familiar with some of them, like vertical angles. Vertical angles. Remember those guys? Remember vertical angles are congruent. We talked about those a couple assignments ago. We talked about parallel lines. Okay. And what kind of angles were formed when they were cut by a transversal? Okay. If you hear a little background noise here, it's because my dog Duke just joined us. Okay. And we also talked about the triangle. Yep, that's Duke having his breakfast. Triangle congruence theorems. Okay, remember side angle side, side side side, etc. Okay, so you should be able to use all those in doing proofs. Okay, we're going to talk about a few other things that we need to do before we get full on into proofs. Okay, the first tool we're going to need to know how to use is our reflexive property. Our reflexive property here. Our reflexive property is simply A is congruent to A. Okay, so A is congruent to A. So that simply means that something is congruent to itself. Where you normally see this, let's say you've got a figure here, it looks something like this. Okay, you got our triangle here. Okay, you got maybe point, sorry, boy, cancel out of that. Okay, let's say you've got in here, you got point A. Okay, you've got point B, and you got point C here. And then you've got this other line right here, okay? Maybe they call that point D, okay? This is simply saying that, say for instance, AB is congruent to AB, okay? Because it's the same thing. That's the same thing, okay? Uh, Similarly, AD is congruent to AD, okay? And where you use something like this, you're showing that this line here is congruent to itself, okay? Let's say you're trying to prove that triangle ABD is congruent to ADC, okay? So you need to show that that side is congruent to itself. Okay, now for the transitive property of congruence. The transitive property of congruence is simply if A is congruent to B and B is congruent to C, then A is congruent to C. So for instance, if I have, okay, this can be used for angles. Suppose I've got this angle here, okay, and this angle here, and say this angle here. Okay, let's put some points out here. Let's call this C. Let's call this B. Maybe I've got a G here, an X there, and W. Okay, so if I know that angle CBG is congruent to GBX, okay, Okay, so I know that this angle, CBG, is congruent to GBX, and I also know that GBX, okay, angle GBX is congruent to BXW, okay, then I can say that angle BXW is congruent, okay, to CBG. Sorry about that. We're going to call that CBG. Okay. So if this is congruent to this, and this second angle is congruent to this third angle, then this third angle and this first angle are also congruent. That's all it's saying. A is congruent to B, and B is congruent to C, then A is congruent to C. Okay. Angle addition postulate. Angle addition postulate simply says that for any angle, the measure of the whole, or the entire thing, is equal to the sum of the measures of its non-overlapping parts. Okay, so here we go. Let's get some angles in here. We've got, say, this angle here. Okay. And inside there, you've got that angle. So we're going to have some points here. Okay, maybe you got, let's go A, B, at point C out here, and maybe point K. Okay, this is saying that angle ABK the measure of angle ABK is equal to the measure of angle ABC plus the measure of angle CBK. That's all it's saying, okay? Angle addition. So this whole thing is equal to this plus this, because those are non-overlapping. Okay, linear pair theorem. Linear pair theorem, it's going to sound real familiar. It sounds a lot like supplementary angles. The linear pair theorem is if two angles form a linear pair, then they are supplementary. Okay, they're supplementary angles. So here's what this looks like. I've got a straight line here. Okay, maybe I've got point A here. I've got point Z here. And I've got this other line right there. Okay, let's call this point C. And I've got D there. Okay, that's saying that angle ACD and angle DCZ are supplementary. Okay, so remember those measures are going to add. Okay, I'm going to abbreviate that. That means that this whole thing here, okay, that means this whole thing, yep, sorry, wrong tool there. Okay, this whole thing here, oh boy, that whole thing there is going to equal 180 degrees. Okay, this whole thing right there. Okay, so that means this plus this, okay, have to equal 180 degrees. So they are supplemental angles. Okay, let's take a look at a few more here. Okay, a couple more examples. Okay, so we got two more here. We've got our segment addition postulate and our right angle congruence theorem. Well, these simply state that For any segment, the measure of the whole is equal to the sum of the measures of its non-overlapping parts. Well, this thing is real similar to the angle addition postulate, okay? So if I've got a line segment here, okay, I got point A, I got point B, I've got point C, okay? This is simply saying that AC, okay, is going to equal AB plus BC. Pretty straightforward, okay? Right angle congruence theorem says that all right angles are congruent, okay? So that means if I've got triangle here, right triangle here, okay? Okay, and this is angle C. I got another right triangle over here. Okay, and this is W. This is simply going to say that angle C is congruent. I got to mark that as right angle to angle W. Okay, all right angles are congruent. Sounds pretty basic because remember, all right angles have a measurement of 90 degrees, but that's what you'd say. You'd say that all right angles are congruent based on the right angle congruence theorem. Wow, that is a mouthful. Let's take a look at our last couple. Okay, our congruence definition is simply, okay, objects with the same measurement are congruent. Okay, so if I know that the measure of angle ABD is, say, 60 degrees, okay, and I know that the measure of angle XYZ is also 60 degrees, okay, I can say that angle ABD is going to be congruent to angle XYZ. Okay, that's all that means. So if two things have the same measure, then they're going to be congruent. Same thing could hold for line segments, angles. Okay, pretty straightforward. The definition of of perpendicular lines. Well, perpendicular lines are simply intersecting lines that form right angles. Okay, so that's just in case. Okay, you're saying you're given something like, okay, for instance, you're given something like, whoop, sorry, I gotta get my pen back here. Okay, if I'm told that BC is perpendicular to, say, XY, okay, I know that the angles formed are 90 degrees. Okay, so if I were to sketch that, if I have BC, okay, and XY, point B up here, point C down there, I got point X here, I've got point Y there, okay, I know that these angles are 90 degrees, okay? That's usually going to be used in conjunction with the right angle congruence theorem, okay? Let's take a look at a few examples of how you'd use these. Okay, now for our first set of examples, we're going to refer to figure one. Figure one's right here. We've got this funky looking shape here with A, B, C, D, and E, all points there. Okay, first thing I want to know, what's going to prove that BC, okay, BC, this line here, this line here, is congruent to itself, okay? Well, that's pretty straightforward. That's going to be our reflexive property. Okay, we talked about that. That's going to be our reflexive property because that's simply saying that something is congruent to itself. Now, what proves that ABD, okay, so ABD okay, this angle right here, is congruent to ABC plus DBC. Okay, well, I've got this big angle made up of this angle and this angle. Well, you know what that's going to be. That's going to be our angle, whoop, not our ankle, A-N-G, angle addition theorem. Okay, angle addition theorem. Okay, because the big angle is made up of those two smaller angles. What proves that BC? Okay, so this segment is made up of BE and CE. Well, kind of what we saw before we saw that it was angle addition. Here we're talking segment addition. So that's going to be our segment addition theorem. Okay. Now, if BE, so right here, if that equals, get rid of that. If that equals 3, okay, so if BE here equals 3, and we know that CE equals 3, what's going to prove that BE and EC are congruent? Well, that's simply going to be our definition of congruence. Okay, remember, if two things have the same measurements, that means they are congruent. Okay, if two objects with the same measure, that's showing that they are congruent. Okay, so those would be 4 examples that we can get off of this figure. Let's take a look at our last set of examples. Oh, by the way, as we're finishing up here, I want to tell you that the magic word for this video is bacon, B-A-C-O-N. Okay, continuing on. Okay, so what proves that FGK is perpendicular to, sorry, what proves that FK right here is perpendicular to GH? Okay, well, we can see right here, this angle is 90 degrees. So that's going to be the definition of perpendicular lines. Perpendicular lines. Okay, what proves that FKG, so this angle right here, is congruent to HKF. HKF. So this angle congruent to this angle. Well, that's our right angle congruence theorem. Okay. Right angle congruence theorem. I'm going to put those in bold for you. Okay, if MFG, okay, this guy right there. So if this guy is congruent to GFK, okay, and we know that GFK, this guy right here, is congruent to FHX, okay? What proves that FHX is congruent to MFG? Well, that's simply going to be our transitive property. Okay, if A is congruent to B and B is congruent to C, then A is congruent to C. Okay, there you go. And lastly, we want to prove that FHX and WHX are supplementary angles. Okay, what proves that those are supplementary angles? Well, that's going to be our linear pairs theorem. Okay, our linear pairs theorem. Remember, we said that any two angles, Okay, if we have a straight line and an angle that cuts through it right there, okay, this line cuts right through it. So this whole angle that equals 180, okay, that means that this angle and this angle are going to be supplemental, okay? This whole thing is 180, okay, so that means this and this are supplemental. Okay, hope this video is helpful for you. If you have any questions, see me in class. Thank you.